Hello there, Evie here, and welcome to my review of the Cooler Master MasterAir Pro 3, a budget 140mm tall CPU air cooler. So, if you want to check out the price of this cooler in your various regions, you can head to the Amazon affiliate links in the video description, and if you purchased anything through those, such as the cooler or some toilet paper, it will give a small kickback to the channel between 4 and 12%. So without further ado, I don't think there's anything left to discuss, so let's get straight into it. Starting with the packaging, the MasterAir Pro 3's box is clean, well styled and informative with plenty of information. But before this box puts me out of a job, does this look like my job to you? What do you mean no? Breaking open said packaging presents a continuation of the clean style, and if like me you too are a previous Hyper 212 Evo owner, you might feel a certain amount of familiarity here. The manual has a very simple layout of instructions, opting for images over text. It's a pretty smart move for a cheap product. I mean, it doesn't take a lot to translate a picture. So all in all, we have an extra set of fan clips, a universal X bracket, and a set of no, oh god no. Okay, let's all calm down, take a step back and work out why they're here. So it's a little weird, but let's go through it. The X bracket is compatible with both Intel and AMD sockets, minus the AM4 socket, more on that in a second, which is an alright start, but the push pins are only compatible with these sockets. Reading from the box, Cooler Master say the X bracket is sturdier, but the push pins are simpler, which is kind of true, but the push pins compatibility is very limited. I honestly don't see many people using them over the X bracket, which while this is an interesting inclusion and useful for some, it seems more like a waste to me, but maybe I'm missing the point. On top of that, AM4 owners or prospective owners, you'll need to spend an extra £5 or $5 or so for an upgrade pack, which only adds compatibility and certainly doesn't add increased performance to the cooler. So it's more of a side grade kit, which means the performance per dollar value of this cooler will drop significantly. Anyway, back to a more straightforward set of hardware. This is almost identical to the Hyper 212 Evo set, only there's an updated included thermal paste and foam pads over the original rubber pads. More familiarity can be found from the backplate, which suits Intel and AMD sockets. I'm more of a fan of the updated finish from the Hyper 212 Evo here. The metal and plastics of the MasterAir Pro 3 have a more satin finish, where the old Hyper 212 Evo has a very glossy finish. Moving on to the actual cooler, we have a lot of plastic packaging here, which is alright, but I prefer to have cardboard for its stronger recyclability. Anyway, enough about that. Here we have the Cooler Master MasterAir Pro 3. Starting off with the basics, we have the standard 4-pin black connector for PWM control with a nice plastic sleeve, which I'll maintain is better than rubberized variants. As for the fan itself, it's a 92mm fan on a 117mm wide cooler, which only really makes sense in the context of the fin stack height behind the cooler. It has to be noted that a larger fin stack and fan would add more to the final cost, which is perfectly acceptable, but not for a budget cooler like this. I'm really happy about the updated fan clip style. These have a far better style than the previous versions and are wonderfully simple and effective. These of course connect to the corners of the fans by screws into a rubberized bracket. Speaking of which is very nicely detailed. This appears to be a new style that Cooler Master has implemented into much of its fan range. The addition of Allen head screws into the fan's frame that don't go all the way through look really classy, and for some reason I thought it was necessary to show you this applied to all the corners of the fan. Why wouldn't it be? Removing the fan is as simple as it possibly could be. If this cooler was mounted to a board, this could easily be a single-handed maneuver, which is excellent. On top of the additional push pins, here's another new feature I've not come across until now. The foam pads go all stripy after being pressed against the fin that wasn't it. The switch at the back of the fan. This appears to be mimicking something like the low noise adapter from Noctua, but in a more convenient fashion. As long as you forget you can control the fan speed in the BIOS. Speed breakdowns will be part of the noise testing later though. Anyway, we've focused on the fan enough for now, let's take a quick look at the bare cooler. The front and back of the fin stack has a staggered profile to raise and lower pressure across the fin stack. This seems to be an ongoing trend with so many coolers these days, so I can only presume it's doing something positive. The top of the cooler has a black painted fin with the Cooler Master logo pressed into it, and there's not really much more to say about that, other than the tops of the heat pipes are crushed, which is pretty typical for a cheaper cooler. I think it looks pretty good being copper, but that's of course up to the individual. Something I've not actually mentioned is this cooler has 3 heat pipes, but it was pretty obvious just by looking at it, and based on the Cooler Master Pro 4 having 4 heat pipes, I can only assume it's a direct link from the number in the name. These are laid out in a standard U shape, which runs underneath the aluminium baseplate, forming Cooler Master's continuous direct contact 2.0 baseplate system. This apparently increases surface area over CDC 1.0 by 45%, but we'll see how this fares in thermal testing results later. After an awful peel-off transition, the cooler moved a bit. A closer look at the base plate shows how rough it looks. I know thermal paste will help here, but I'd be interested in finding out if sanding and polishing this up would help performance. And just before we get into the installation part, the bottom fin reveals a series of holes set out in a wedge formation. I presume this increases air pressure to the center of the fin stack, encouraging more airflow to the sides of the stack where the heat pipes are located. As for the installation, here's all the hardware we're using to mount the MasterAir Pro 3 to an LGA 1151 socket. Starting off with the backplate, since I rushed the test bench together, I went with the first power supply unit to hand, which turned out to have a CPU cable only just long enough to get to the top connectors. So working around that, the backplate can be held up to the motherboard tray around the back, and what are essentially some really beefy standoffs, PC hardware wise, need slotting through the mounting holes in the front. The bolts are not entirely circular, which allows them to be slotted through the backplate and then be rotated to clutch onto the arm. It's effective enough to hold the backplate in place with just one, at least for a few seconds, but of course one won't be enough, so the other three need to be installed as well. Then a set of nuts can be tightened down over the previous bolts, which finalizes the mounting platform on the motherboard. Next up is thermal paste. I'm not going to be using the included thermal paste, instead I'm using our control thermal paste Arctic MX2, and we're using a lot here to ensure full coverage, more on that later. Now comes the cooler, and here's where things get a little awkward. The X bracket needs positioning between the heat pipes with its center post slotted into the hole in the center of the base plate. It's not the worst solution to mounting a cooler, but it's quite a bit fiddlier than others on the market. Anyway, once it's in position, it's just a case of evenly tightening down all of the screws until you've hit the limits of their travel. I tried supporting the cooler during the vertical installation part to prevent it from sagging and causing an uneven spread of thermal paste. So with the cooler in place, the fan can now be remounted, connected to the motherboard, and the RAM can be put into position. It's pretty obvious, but worth pointing out that there is no RAM clearance issues with this cooler. The fan isn't even close enough to cause a clash. So as for the noise and speed testing, in the background now you can see the original test footage, which lasted 8 or so minutes, which is way too long for such primitive testing. So instead, what we're going to do is something different. At the end of my talk now, we're going to listen to back-to-back footage of the two different fan speed profiles, which if you remember back to when we checked the fan out, there was a 2-position switch on the back of the fan. There was the S and Q position. S stands for silent and Q stands for quiet. Those are two different fan speed profiles. So what we're going to do is listen to back-to-back footage of those going through 20% speed, 60% speed, and 100% speed on a PWM fan control, and see what it sounds like. So without further ado, let's check out that footage now. Something I'd like to clarify before getting into thermal testing is the thermal paste spread. What's the point of a cooler review presuming the mount is perfect every time? So after removing the cooler from the motherboard, it appears that there was some missing coverage to the corners of the base plate of the cooler. As for the CPU's IHS, this confirms the poor thermal paste spread. It's not even a case of vertical mounting installation issues. The missing corners are to the right, top, and bottom. You'd have thought through the sheer volume we applied earlier guaranteed a proper spread. It was 90% there, of course, and in the right places, but maybe a central post bracket isn't the most foolproof solution. Perhaps a more pre-spread thermal paste application would be more reliable for this mounting solution. So before we get into thermal testing, to guarantee full coverage, I topped up the corners in need of more. So after topping up the thermal paste, I remounted the cooler and proceeded to test this thing 6 days to Sunday. Sort of, within reason. So as usual, let's run through those test results, but first, a quick breakdown of how the graphs work. The grey bars represent FPS, frames per second, which doesn't change an awful lot, hence why they're in grey. The blue bars represent CPU temperatures in degrees Celsius in a delta T format, meaning the ambient temperature of the room has been subtracted from the component temperature. This normalizes the results and makes them more directly comparable. The purple bars represent the cooler height in millimeters, which is how these graphs are ordered. This may change in the future, but it gives a rough idea of size to performance without going through another graph. And finally, all fans on the test bench were set to 100% speed to remove any fan curve variables, and I have tested both the full speed silent and quiet modes of the MasterAir Pro 3, which I'll highlight as we go along. So without further ado, let's get into this. We're going to skip past the lighter CPU load results since they don't have a lot to show. So, starting with the Firestrike physics test, the silent mode came in at about 1.5 degrees hotter than the quiet mode, and while both variants of the MasterAir Pro 3 are where you'd expect them to be, between the CPU coolers just bigger and smaller than it, the 20mm smaller NHD9L has nearly 3 degrees Celsius lead on the quiet mode Pro 3. Moving on to the combined test results, the results normalize a little here since more load is placed on the graphics card, but the rough order of the results is the same as the physics test. Skipping past Unigine Heaven, we're going to take a quick look at Unigine Superposition. This is a low CPU load test, it's pretty much graphics card dependent, but I would like to draw your attention to the Hyper 212 EVO result in comparison to the MasterAir Pro 3's results. They're pretty identical in terms of low CPU load thermal performance, but when we switch to Rise of the Tomb Raider, both MasterAir Pro 3 results are below that of the Hyper 212 EVOs. Hitman shows us more of the same. The thin, dense 120mm tall D9L is outperforming the MasterAir Pro 3, and the Hyper 212 EVO is near enough matching the Pro 3. And just before we check out the Pro 95 Ultimate Decider test, GTA 5 shows us basically the same results as Hitman's, only a few degrees hotter. But the question is, can the Pro 3 keep far enough ahead of the Purox Slim and the Cryorig M9i to be worthy of the extra height in the Prime 95 torture test? And the answer is, sort of-ish. The quiet mode result does manage to stay a couple of degrees ahead of the 125mm tall competition, but the silent mode turns the tables on that and ends up being pretty much a couple of degrees hotter. As for the fight between the Pro 3 and the Hyper 212 EVO, they're nearly neck and neck, but not quite. And it has to be said that the Hyper 212 EVO is far quieter at full speed than the MasterAir Pro 3. So there we have it. That was probably one of the smallest B-roll segments I've done on the channel. Well, pretty much there's not a lot more to see that we haven't already seen, so I wanted to cut it quite short. But anyway, something I wanted to discuss before I go any further and finalize this review, this video, is I'm sure there'll be one person that will say, you shouldn't have remounted the cooler after taking it off because there'll be air pockets, you should have cleaned the thermal paste off, and think of the children, something like that. I wanted to say that I actually have retested this cooler on the Pro 95 small FFTs test with the silent mode after an entirely new thermal paste application. So you can see the background footage, or you will have been seeing the background footage sort of opaquely put over this, opaquely? Something. Anyway, it'll be sort of merged over the top of this video. So yeah, I did a complete retest, and I found these results here, is that there was 0.6 degrees Celsius improvement, which is as far as you can be within tolerance of the sort of standard silent testing, where with the sort of old thermal paste or whatever like that. So frankly, it's made literally no difference. I was going to make an entirely different video saying, oh, what's the difference between taking it off and putting it back on and that sort of stuff, and retesting for that sort of stuff, but frankly, I wanted to be thorough, so I did the testing now, and the results are 0.6 degrees Celsius improvement, which is within tolerance, so it may as well be completely negligible. So that's that. I know there'll be edge cases where people will say, actually, well, you did this and didn't do that, but frankly, as far as the testing is concerned, it's completely fine. I may do testing in the future because this cooler has push pins and a sort of steel mounting bracket. I may do testing between push pins and a mounting bracket, but frankly, I don't really see there's going to be much of a difference between those either. So rounding off the actual review part, starting off with the bracket, closing thoughts on that, it's really not, the mounting solution, really not the best one. It makes vertical mounting very difficult. It's a single point of contact between the mounting bracket or the mounting mechanism and the base plate of the cooler, so that's not as strong as having, say, 3 or 4. I know 3 is a weird number, but if you were to make a chair, let's say a chair to be properly balanced, you probably wouldn't want one 5mm leg. You'd probably want, I'm saying that the post is about 5mm wide. You wouldn't want one 5mm leg. You'd probably want a minimum of 3, but because it's mounting to a socket, you kind of want 4. But I suppose you could have one bracket across and then 2 mountings on there, so 3 would make sense. But anyway, you would ideally want more than 1, at least 3. So I don't think it's the most robust in that sense. It allows for pivoting of the CPU cooler on that base plate or on the CPU IHS on the thermal paste. So hence why you can end up with the issues I found. So that's not great. So yeah, in terms of thermals, pretty competent, nothing too bad. It was comparable with some of the 125mm coolers in lots of scenarios, so perhaps not the best performance it could have. It only has 3 heat pipes, so I suppose that's one sort of downside to it, but again, it's more of a budget cooler. It's not like £40, it's more like £20-25, so that's not too bad. In terms of styles, that's subjective, and in terms of acoustics, in terms of noise, just a bit too loud on the quiet end. Quiet should be made into a performance category, and the silent should be brought up into quiet. Now, I'm not sure if Cooler Master would regard that the quiet noise, the quiet level at, say, full speed is actually quiet. If so, what are their offices like? I can imagine all the computers are extremely loud. If that's what they regard as quiet, they should shift it up. If the quiet mode was set as performance, I couldn't complain because it's really pushing to get the most. And if the silent was shifted to quiet, I'd say that's actually fairly quiet at 2000 RPM. So that should be shifted. It's a bit misleading to have it the way it is. So yeah, it is noisy though on the quiet level, and it is relatively quiet on the silent level. So that's my closing opinion on that. So that's that. I'm going to close the book there, sort of metaphorically or figuratively or something like that. If you want to support the channel, you can like, dislike, or comment on the video. Consider subscribing to see more like this. I do other reviews and stuff you can check out in the top right hand corner. And yeah, if you want to go even further than that, you can join the Patreon and donate whatever you fancy to the channel to support it in terms of buying all sorts of stuff. Also, remember the Amazon affiliate links are available in the video description if you do want to pick this CPU cooler up. So thanks for checking this out, and I'll catch you in the next one. Bye bye.